Okay, good morning to everyone. Last class, we have been discussing on the concepts of time response specification. If I just take up the equations, whatever we studied in the previous class. So in the previous class, we have studied the equation for time response specification for second order system. So here we have studied rise time, that is TR, and so we got the equation for that rise time, and we calculated the equation as pi minus phi by omega n root of 1 minus zeta square. This was all obtained in the previous classes, just to make you clear all these things. The second thing what we have studied was peak time, and this is the equation what we have to use it in the problems. Tp is equal to pi by omega n root of 1 minus zeta square. The third one is maximum overshoot MP, and we will be using this equation for MP, that is e to the power of minus pi zeta divided by root of 1 minus zeta square. Then further we have settling time. We have gone with the equation Ts is equal to 4 divided by zeta omega n, and the final thing is delay time Td, and we have gone with this equation Td is equal to 1 minus 1.1 plus 0.125 zeta plus 0.469 zeta square by omega n. So these are the equations which we have been discussing in the classes here, and now we will discuss further with some problems. So we can start with the first problem. So you know that in control system we'll be asking problems for you to solve. So you may have to use all these equations in order to find out all these parameters. So first write down this problem. A negative feedback system is characterized by an open loop transfer function is given for you. G of s, h of s is equal to 10 divided by s, 10 divided by s into s plus 2. So take up this equation. This is the equation for transfer function. Find the following time domain specification. First one is rise time, then you have to do peak time, then settling time, peak overshoot MP, and assume the system is excited by a step of 1 volt. So this is what you are having here. So we will be taking that 1 plus g of s h of s is equal to 0. So all of you first note down this equation, then we will be in the process of finding all the 4 parameters and how to solve it. It's very easy. Just use the equation, substitute it and solve it. It's not difficult, and everyone can do it. Only requirement here is you need to remember the equations for rise time, peak time, settling time, and peak overshoot MP. So all of you note down this problem. So within another 1 or 2 days, since if anyone is left out with assignment 1 or anything, so you can just complete it. Again, I don't want you to remind these things. Once the assignments or quizzes are given, immediately you complete those things. Okay. So this week I'll be giving one more, so you can complete it by Saturday will be the deadline. So you can complete it by Saturday. So we'll be doing some problems, extra problems on a signal flow graph and all those things, which was there in the second module. Once you complete that, then we will go further in the syllabus and give later on further more problems. So complete the question and try to solve it. All the equations are there with you. So if anyone has got the answer for TR, that is rise time. So I will since it is a first problem, we will see how it is to be solved, and then you can once we do it for TR, rest of the things it will be easy for you. So you complete the question. Is the question completed?
Yes, sir.
Okay. So we have this equation, that is we have studied that 1 plus g of s h of s is equal to 0, and by using this equation of 1 plus g of s h of s is equal to 0, so g of s h of s is 10 divided by s into s plus 2. So I'm going to substitute here, so I'm going to get 1 plus 10 divided by s into s plus 2 is equal to 0. So I get the equation in this form. So we can put it as equation number 1. So all of you can solve it and get till equation number 1, and then we are going to compare the equation 1 with the reference characteristic equation. So we will see that, and then we are going to simplify it further for all these values. So we got s square plus 2s plus 10 is equal to 0 as equation number 1. So all of you have completed till there?
Yes, sir.
Yes, sir.
Okay. So now we have to go back and see what is the characteristic equation we have studied in the previous class. What was the equation I told you you should remember as the characteristic equation? Any one of you remember that? Characteristic equation for second order system. See, make sure that you study daily, and see here we have mentioned here characteristic equation s square plus as plus b is equal to 0. We are doing it for a second order system. So all of you should remember these equations. You need to go back and study all these equations so that it will be easy for you. So comparing equation 1 with the reference characteristic equation. So what was that equation we have seen? Once again, I'll take you there. So this was the characteristic equation where we have substituted A and B in the subsequent class, and we got the final equation in this form. So it is like s square plus 2 zeta omega n s plus omega n square. So this denominator is what we call it as the characteristic equation, s square plus 2 zeta omega n s plus omega n square. Again and again, you should remember these things, each whatever we study in every class. So one or the other things will be interrelated to the other topic. So this is what the characteristic equation is, s square plus 2 zeta omega n s plus omega n square. So here we are going to use that equation, that is s square plus 2 zeta omega n 2 omega n 2 s square plus 2 omega n zeta s plus omega n square is equal to 0. So now when you compare these two equations, you need to compare the equation 1 with this equation. So let us compare these two equations, and let us see that how it can be further simplified. So you can see that it is 2s, and 2 can be this term, this complete term. So we get as omega n square as 10 as well. So you need to compare these things. So we are just comparing it and simplifying it further. So we get 2 zeta omega n is equal to 2, and omega n square is 10. Till that all of you will get it. You just simplify till there, and then we will continue further. So you got omega n square is equal to 10, you got omega n, you can substitute, you can get zeta. So from this equation you can get omega n, and from after getting omega n, you can substitute in this equation and get zeta. So you get omega n as well as zeta. It's very easy to score marks for these problems. Only thing I am saying you need to remember the equations for rise time, peak time, settling, and overshoot time. This one, and you should also see that whether it is a first order system or a second order system. So all those things you need to check. Okay. So all of you will get zeta here. So anyone of you got zeta? Let me know whether the answer is correct. What is the value of zeta? See, what is omega n is root 10. So from that you can get zeta.
1 by root 10.
Yeah, what is that value? Okay, we will take it as 1 by root 10 and it is 0.316. Okay. So zeta you will get it as 0.316. All of you are getting 316?
Yes, sir.
Okay. So you got omega n, you got zeta. So what is now you have to find out in the problem, rise time, peak time, settling, and overshoot. Now we are going to see one by one. Just so what you can see here, zeta is what you get here is 0.316 and zeta is less than 1 indicates that it is an underdamped system. So all of you should study the previous topics. You know that zeta less than 1, you call it as a underdamped system. So now we got zeta value, you got omega value. So what is that we have to find out? The first one is rise time. So what is the equation for rise time? See, I am not going to show you the equation as of now. You can refer the previous class. So here the equation is there. I want you to go back, write the equation from the previous class and substitute and solve it and let me know that what is the value of TR. That's what you have to do now. Do it and just if any one of you get the value of TR, just let me know that. So this is the equation for TR which we have studied, pi minus phi divided by omega and root of 1 minus zeta square. So omega value you know, zeta value you know. You think how to find out phi, then after that you can substitute those things. So try that problem. I have brought you till zeta and omega. So now we have to find each parameter. So I have also written all the equations for phi everything. You can use those things and find out phi, substitute it and simplify it. What is the equation for phi? Refer the previous class and let me know that what is the equation for phi. Any one of you?
Tan inverse of under root 1 minus zeta
Yeah.
square by zeta.
Yeah, that is correct. You use that equation, find out phi, substitute all the values and simplify, and finally you tell me what is that answer. See, I asked you to learn MATLAB in the previous class. Any one of you have started learning MATLAB? Okay, you can just start learning MATLAB. Try to learn when you are free. Try to learn MATLAB, and so that we can do some small mini projects when we study Ruth Hurwitz criteria, or we study Bode plots, Nyquist plots, and all those things. You can see that this can be executed in the MATLAB, and we can get the observations, and we can do it. So you can try using MATLAB in order to do all these things. But before trying MATLAB, it's important for you to study the MATLAB tool. And I want you to do it. Try studying MATLAB, and try to execute some code, or some try to write something, whatever you feel. You explore that tool, and it will be useful for you even further when you carry out any research, not only in control system, any of the domain. So MATLAB is very much important for our electronics branch, and it has a lot of value. So you have to know that how important it is if you are a good MATLAB programmer also. So it's not that all C, C++, Java and all. You can be experts in MATLAB as well. So you have some labs oriented on MATLAB in your higher semesters. So it's always good to learn those tools. So I'll be asking you to submit some mini projects on this subject by using MATLAB tool. So you have to learn those things. I'll try to send some videos and all, so that you can refer to that and learn. See, I'm not seeing any response from your side. You are very much straightforward. If assignment is given, you write it. Quiz is given, you do it. Rather than that, you don't think beyond. You need to think beyond, out of the box, and try. So, any one of you got the answer for the first one? You are still doing? So what is the answer for 5, first of all?
71.57.
No. You have to do it in radians. See, omega is 3.16 radians per second. So here also you'll get all these values. How much you're getting? You'll get, any one of you got 1.249?
Yes, sir. If you do in radians, we'll get that.
Okay, okay, fine. Okay, then simplify it and get me the first answer.
4.163.
0.631 is what we'll get for TR. Check the calculations in the brackets. See, most of the students make mistake in calculator. It's not that they don't know to do it. They don't put the brackets properly when you take multiplication or division. So they miss out the bracket and they end up in a different answer. So don't do that. Make sure that your calculations are correct.
So this is 0.6307.
Yeah, 0.631 seconds. So once you complete TR, what is the next one to do? Peak time.
Yes, peak time is 1.046 seconds.
1.047 seconds.
Yes.
Correct answer. So all of you do this. First one, all of you complete. You'll get 0.631 seconds. And second one also you do that. Simultaneously, you can use the equations and find out rest of the terms as well. So have you all completed TP as well?
Yes, sir.
All of you got the answer as 1.047. So you'll get TR as 0.631. First, we have to find out phi. Phi, you will use this equation tan inverse of root of 1 minus zeta square by zeta, and you will end up with this equation answer as 1.249. So only thing is that you need to remember that when you do the calculations, you should put the brackets properly. So TR you will get it as 0.631 second. Once you complete this, that one, second one is TP. So you have completed the first one, that is rise time and then peak time. So peak time you will get it as pi divided by omega n root of 1 minus zeta square, and pi divided by omega n and zeta. You know that you can substitute these values, so you'll get 1.047 seconds. So the next one, what you have to do is, next what they have asked you to find out is settling time and peak overshoot. So let us see what is the settling time equation and peak overshoot. It's very easy. What is settling time answer?
3.998 seconds.
Yeah, that's 4 seconds. Fine, correct. So next one we'll see maximum overshoot. So first, before that, we have to see this TS is 4 divided by zeta omega n. You have to use this equation. So when see what you can understand here is, if you know the equations, you can derive at the answers. So please by heart the equations without making any mistakes. But when you're deriving it, you can't keep deriving the equations in the examination, so you need to study these equations so that directly you can substitute the values and you can come to the answer. So you'll get it as 4 divided by 0.316 into 316, you'll get 4 seconds. Maximum overshoot, any one of you got?
0.351.
0.351, so you can write it as 35.1 percentage. Okay, so you'll get MP as e to the power of minus pi zeta divided by root of 1 minus zeta square. So you'll get it as 0.351. You can write it as 35.1 percentage. So those who have not completed, complete it. I will give you another 2 minutes to complete. So all of you complete all the 4 parameters. So once you complete it, we'll go with the next problem. So all of you have completed?
Yes, sir.
What
Yes,
about
sir.
others also? Everyone has completed, okay.
Yes, sir.
Okay, fine. So we have got the answers for TR as 0.631, TP as 1.047 seconds, TS is 4 seconds, and MP is 0.351 or 35.1 percentage. So we will see one more problem. So now you can try doing it because one problem is already done by you. So we will see that. So here, a unity feedback control system is characterized by open loop transfer function is given as g of s is equal to k divided by s into s plus 10. You can see that it is given in terms of k. Determine the system gain k. So you have to find out k as well, so that the system will have damping ratio of 0.5. For the value of k, find the rise time, peak time, settling time, peak overshoot, and assume that the system is subjected to a step response of 1 volt. So a slightly different problem where the value of k has to be found first, and then we have to proceed for the rest of the things like rise time, peak time, settling, and overshoot. Complete the problem question first. So all of you have completed the problem, writing the question. So here you can see that g of s h of s is k divided by s into s plus 10 is given for you. System gain you have to determine. Damping ratio is 0.5 and you can simplify it because it is given that the step response is 1 volt. So first thing what we will do is we'll just know that the second order system is a negative feedback system. So I'm just going to write the draw the diagram for that. So here you know that which you have studied already in the previous topic. So that's the reason I have told you that you need to remember these things. If I go back, so I have clearly mentioned at that point of time, you need to understand and remember these few things which is very much required for the second order system. So I have told you that this is the one block diagram you need to remember, and this is the characteristic equation you need to remember. This is the transfer function equation you need to remember, that is omega n square divided by this denominator. So this representation is what we are going to use here in order to find out further in this problem. So second order system, we know that the block representation is in this form. So please all of you study as and when we come across all these things. So just draw this figure where you can see that you need to know that from where we have taken all these things. So that's the reason if you study the previous classes, it will become easy for you, especially in control system. Make sure that at least by 1 or 2 days you just come along with the subject. So you should study, go through those derivations and prepare not only at the time of examination. It's this subject is like if you study before, no, you will not forget. There is nothing much to forget here. It's not a theory, it's a problematic subject. So it's all practice what is required for you. So omega n square divided by s into s plus 2 zeta omega n. So this is how the second order representation is. Here g of s, h of s is given as k divided by s into s plus 10. So now first responsibility of us is to find out k. So we will see that. So as usual, we know that 1 plus g of s h of s is equal to 0. So here g of s h of s is what? K divided by s into s plus 10. So we will see that we can simplify it and the equation will come in terms of k itself. So it will be s square plus substitute that g of s h of s, you'll get 1 plus k divided by s into s plus 10, or you'll get it as s square plus 10s plus k is equal to 0. That will be equation number 1. So all of you complete till equation 1. We have this value of k as unknown. So we have to find out the value of k and then proceed further. But here some values are given, like damping ratio is given as 0.5, and also it's specified that the step response is 1 volt. So like we did before, you need to write the characteristic equation. So you know that the characteristic equation is s square plus 2 zeta omega n s plus omega n square is equal to 0. So you can understand that 10 is equal to 2 zeta omega n, and omega n square will be equal to k. So omega n will be root k. So till there you got it. So you should know that the damping ratio is given for you as 0.5. So try to correlate and come out with a value for k. I want to see that who can just give me the value for k. So you need to compare this and you get 2 zeta omega n as 10 and omega n square as k. First determine the value of k, and then if you get the value of k, then it is same as that of the previous problem. So if any one of you got the value of k, just let me know that. See, I am saying you damping ratio is given as 0.5. What is damping ratio here? What is damping ratio? See, 2 zeta omega n is given as 10. Omega is given as omega n is root k. Damping ratio is given as 0.5. Find out omega k. Find out k further. See, anyone has got the value of k? See, try whether it is correct or wrong, doesn't matter. You can just say what value you got for k. Deepti, you are there?
Sir, 100.
Yeah, Sai, tell me, any one of you.
100, sir.
Okay, so you have used damping ratio of 0.5, no?
Yes, sir.
Yeah, 100 is correct. So you can do that. What is damping ratio is 0.5. So it is 2 into 0.5. Omega n is equal to 10. You get omega n as 10 radians per second. So k is 100 you will get. So find out rest of the things: rise time, peak time, settling time, and overshoot. So you have to use the equations and check whether you are getting the answer as here. So all of you try one by one. First you find rise time. You maybe don't see here. You calculate and find the value of TR. So these are the answers you are going to get. So it's the same problem what we did before. Or you have to do calculation by substituting the values of omega and zeta. So zeta is 0.5 and omega is 10. So you need to substitute and simplify it. See, only thing is that when you're doing in calculator, no, you are putting all the values together, use the brackets properly. So first value for TR, you got it as 0.242 seconds.
Yes, sir.
Okay. Once you get that, see, you do the calculations in the calculator properly by substituting the values. Don't miss the brackets especially when you are dividing or multiplying. When you are dividing, put that brackets properly in the calculator if you are doing it of one stretch. So knowing the equation and knowing the values, there should not be any mistake in calculation. So, just it is waste of marks for you uh, for no reason. Okay, so calculation mistakes you should try to avoid as much as possible in examinations as well. So TP, answer for TP, that is peak time, you got, whether you got it at 0.363, you have to use, okay, you have to use the equation pi divided by omega n root of 1 minus zeta square. Okay. So next you do settling time, that is TS. You have to use the equation 4 by zeta omega n. You will get 0.8 seconds. Have you got 0.8 seconds? So all of you got 0.8 seconds.
Yes, sir.
Okay. So once you complete it, then you go for peak overshoot, and the equation to be used is MP is equal to e to the power of minus pi zeta divided by root of 1 minus zeta square. Substitute the values for that, and just see that you are getting 0.163, or it is 16.3 percentage. So once you complete the problem, you just let me know that. We will just continue for the next problem. So those who have completed this problem, you just note down this question. We will do it in the next class, that is this problem. So you can just note down the question for this class, and you can complete it if you are, you can try, you should try, and also try to solve it, yeah, and try to see that how to get the values for whatever it is asked here. Try it out. If you're getting it, good. Otherwise we'll be solving it in the next class. So you can just note down this question. Measurements conducted on a servo machine shows that the system response to be C of t is equal to 1 plus 0.2 e to the power of minus 60t minus 1.2 e to the power of minus 10t when subjected to a step response of 1 volt. So first one is obtain the expression for closed loop transfer function. Second one is determine the underdamped natural frequency and damping ratio of the system. So you need to find out the natural frequency as well as the damping ratio of the system. And here you need to find out the expression for the closed loop transfer function. And third one is obtain the unit ramp response of the system. So these are the things you need to find out. You can just note down the problem. If you are able to do it, try it out. What possibility is there to get the answer for this? So whatever it is, we'll be solving it in the upcoming class for this problem. So all of you have completed the second problem.
Yes, sir.
You got peak overshoot as 0.163.
Yes,
All of
sir.
you got it? Okay. So once you complete it, just note down this problem. We will complete in the subsequent class. If you are able to solve it, it is good. So you can just note down the problem. So all of you complete this question now. We will solve this now. It's almost time. So we'll solve it in the next class. So once you complete writing the problem, you can we will wind up for today, and you can subsequently try to solve this problem for the next class. Okay, thanks to all. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
Thank you,
Yeah,
sir.
thank you.